Hey, what's going on, guys? Let's do this problem right here. Here this question is asking time to reach half of its original temperature. So here they are saying initially we have a temperature and how much time will take for the half of its temperature, because the temperature is going to go from hot to cold. So when it's reached half of its amount, what's gonna be the time? Now let's see how we can find using this information. Here we have Q dot, and for radiation, Q dot is equal to emissivity times Stephen Boltzmann constant times the surface area, right, times temperature power 4. So this is going to be the equations. Now also we know that dq is equal to mc dt, and since this temperature is decreasing with time, this is going to be negative, because we know that this is for increasing equation, but when it's decreasing, this is going to be negative mc delta mc dt. So we can replace this dq with this value. Now let's go ahead and replace this one and solve this, right? So here we can replace this dq with negative mc dt over d time is equivalent to emissivity times Stephen Boltzmann constant times surface area times t power 4. Now we can arrange like terms together, because in that way it's easy to integrate. Now let's move all the temperature to one side and the others to the other side, right? Here we are going to have dt over t power 4, and in the other side we are going to have this is emissivity times sigma as times dt over mc, right? And there's a negative sign right here. Now let's do the integration. When we do integration, we can write this one as t power minus 4. In that way it's easy to integrate. So this can be written as t power minus 4 dt, right? And the temperature is going from T naught to T naught by 2, because in the question they are asking time to reach half of its original temperature. T naught by 2 is going to be half of this initial temperature. So that's why it's T naught to T naught by 2. And in the other side we have negative epsilon sigma as dt. So I can integrate this dt too. If I integrate this time is going from 0 to t, right? So this is going to be 0 to t dt, this is going to be 0 to t, and then we are going to have mc in the bottom. Now let's simplify. This is going to be t power negative 3 over negative 3, and that's going from t naught to t naught by 2. And in the other side we are going to have negative epsilon sigma as t over mc, and this t is going from 0 to t. This can be written as negative. Also I can move this negative to the other side, right? Negative 3 to the other side. If I move this one, this is going to be positive 3 right here. So this is going to be positive 3. If I move this positive 3 right here, because negative that's going to be positive, and we are going to have t power minus 3. T power minus 3 is same as 1 over t cube. So this is going to be 1 over t cube. If I write this one in terms of first one, this is going to be t naught cube over 8, right? Over 8. So when we write this over 8 in the bottom, that's going to flip around and goes to the top. So this is going to be 8 over t naught cube. For the other one, it's going to be just 1 over t naught cube. And in the other side, we have 3 epsilon sigma as surface area, and then we have t. So when we have t, it's going to be t. When we have 0, the whole thing is going to be 0. So we can just write t right here. And in the bottom, we are going to have mc. Now let's simplify this one. This is going to be 8 minus 1. That's going to be 7 over t naught cube. That's going to be equivalent to 3 epsilon sigma AST over MC. Now our purpose is to find the time. Now let's move this around a little bit. I need more space, right? So I get rid of this part right here. So let's remove this one. Okay, let's continue. So here we are going to have, we are trying to find T. T is equivalent to T naught cube 3 epsilon sigma AS. You know what? If I move this one other side, that will be much easier because T is on numerator. So it's better to keep this side T, and if I move other things to the other side, this is going to be 7 MC over 3 epsilon sigma AS T naught cube, right? Now this is mass. We know that mass is rho times V. So mass can be written as rho times V. And the volume for a sphere, this is sphere shape, so volume for a sphere shape is going to be 4 by 3 pi r cube. Right, so if I write this one in terms of this, it will be helpful because here we have surface area. So we can cancel this pi and r with that one. So let's write this one in terms of this pi r cube, right? So this can be written as 7. Instead of mass, I replace this one with rho Vc. Instead of V, I can write 4 over 3 pi r cube. So this is going to be rho times 4 over 3 pi r cube and C. And in the bottom, we are going to have 3 epsilon sigma. Instead of surface area for a spherical shape, the surface area is going to be 4 pi r square. So instead of writing AS, I can write 4 pi r square right here, right? And then we are going to have T naught cube. Now let's cancel everything we can cancel. First we have r square right here. That can be cancelled with this cube. And also this 4 can be cancelled. And then we have this one left, right? Now let's see how we can simplify this one. Also we can cancel this pi, right? Now let's do the simplification. Here we are going to have 7. Also this 3 can be brought to bottom. So this is going to be 7 over 9. Rho. Rho RC over epsilon sigma T naught cube. And that's going to be our final answer. I hope you guys find this video helpful. See you next time.